All right, so mastering physics again, chapter 27. This is question 15, chapter 27. So the problem is the starter motor of a car engine draws a current of 100 amps from the battery, and the copper wire to the motor is 5.9 millimeters in diameter and 1.2 meters long. The starter motor runs for about 0.93 seconds until the car engine starts. So the first question is asking us how much charge passes through the starter motor. So looking at our equation sheet, I can see charge. I see equation Q equals the amp times the change in time, and that actually is what we're going to be using. So the charge, right, I is already given to us, that's 100 amps. So if we do amps, which is also volt over, what is it? Or coulomb over second, I'm sorry, coulomb over second, times it by time, which is just 0.93 seconds. Seconds cancel, we're left with coulombs, and that's just going to give us 93 coulombs, which is exactly what we got there. So that's good. Number two, part B, how far does the electron travel? So looking at the equation, I want to show you guys, how I kind of messed up the first time for doing this. When I first read travel along, how far, you're thinking length, right? And you guys can see answer. Obviously, the answer is in length. So I'm thinking length, right? Let's go ahead and use the equation that has length in it. So I looked at this one, R equals PL over A, right? But this doesn't help anybody, right? Because we can find P from the book. That's the resistivity, and that's the resistance, right? We know the resistivity because we can find that in the table of the book, but we don't know the resistance because, well, I guess we can calculate it, but then we're just really going in a circle because to calculate resistance, we're using this length, and obviously, or not that length. Yeah, that's the length. But obviously, if we were using that length, it did not travel the whole entire length, obviously, or it wouldn't be asking this question. So the correct equation to use is actually, believe it or not, you guys might already know this. I is equal to N, which is the electron density, okay, not the charge density, of the metal. In this case, it's copper. I'm going to have to get that from the book. And the charge of an electron, and then V, the drift velocity times A. So the drift velocity, that's the velocity, but we also given the time it takes for the engine to start, which is 93 seconds, or 0.93 seconds. So if we get the velocity in meters per second, we can multiply by the time in seconds, then we'll get meters, which is what we want to solve for that, okay? Basically a length, okay? So don't get that mixed up. So real quick, looking at the book, we know that the electron density, or not the electron density of copper, I actually don't know what that is, so let me go get that for you guys real quick. All right, obviously I don't have this table memorized, but I just got it quickly from the book. It's 8.5 times 10 to the 28, 1 over meters cubed for that. So let's go ahead and just use the equation, solve for V of D. We get V of D by itself, so let's just move everything to the other side. I'm just getting quite repetitive now, so it's just going to be N, E, and A. Well, we got to find the A again, but we're given the diameter. So off to the side, let's find A. A is equal to pi r squared. So we're given r, but it's in millimeters, so it's going to be 5.9 e to the negative 3. We're going to divide by 2 because it gave us the diameter, and we square it, right? So A is going to be equal to, if I do this in calculator pretty quickly, hopefully this is right. 2.734 times 10 to the negative 5 meters squared. Yep. So, and then we can just go ahead and plug everything in because we have everything now. So I was 100 amps. That's the current. Let's just go ahead and remember 1 amp is 1 coulomb per second. So this is, because we know it's going to be meters per second. So let's make sure units cancel out properly. And that's just going to be from the book right here, 8.5. E28, 1 over meters cubed. That's a 3, if I can. Okay, that's a 3. That's what it is. Okay, and then we're gonna have, where's my equation? E. So that's just 1.6. You're not going to have negative velocity, so I'm just going to disregard all negative signs. It's probably a really bad thing to do, but you know, it's okay. And then we're going to have, where did it go? Okay, A, which is what we found right here. So 2.734 e to the negative 5 meters squared. Extend my division line. Meter squared cancel with this cube right here, so we're left with 1 meter in the bottom, but this will get flipped because we're dividing, so meter goes to the top. Coulomb cancels this coulomb, so we're just going to be left with meters per second. So 8.5 e to 28 times 1.6 e to negative 19. I'm just typing this in a calculator. So I get 2.69 e to the negative 4 meters per second. We're not done yet. We got multiplied by seconds, which is 0.93 seconds. So seconds cancel. And then we are left with 2.501 times 10 to the negative 4 meters. Okay, now we can convert that to millimeters because that's what the answer is in. So let's multiply by 1,000 and we're left with 0.25 millimeters. And that is a really short distance. And that's it, guys.